All right. Jim Tommaney, Calpont. Our product is InfinityDB. The only slide you'll see on InfinityDB is here. We're scalable. We have MPP scale-out capability. Fast. We use Columnar storage to get very efficient I/O for large analytics queries, common compression. Very easy to use. It's kind of a drop-in, load-and-go scenario. So the topic itself today is really what are the workloads suited for columnar databases versus row databases. The talk is in it's abstracted from our technology and talks about columnar storage in general, what it's good for, and suitability. So when you talk about access to data, we're going to look first at traditional access methods, and this is not going to cover all possible combinations, but effectively there's a table, there's some access methods, some index or some hash structure allow access to the data, so you can get a few records, you can get many records, and different ways to get at the data. And if it's not indexed, obviously it's a full table scan, which can be problematic. But then there's partitioning. You can actually have partitioned operations against these things. So you can actually go do individual accesses. You can get many records. There's one item in here. The get many is can be an operation that some databases have where they'll actually use an index structure or a hash structure and actually walk that serially rather than walk the index tree, and they'll effectively treat it like a column to scan. But that's an optimization that's available in, for example, Oracle's a fast full scan. There's a million other ways this can be done, but this is a 5-minute, not a 5-hour. So columnar DB mess. Generally, they all partition the data vertically by column, and then horizontally by some other method. So the method differs in general, but there's always some ability to divide and conquer into many, many discrete objects that can be accessed individually. As a general statement, the block touches to get those are traditionally scans against those column structures, and then those are processed in serial manner to apply filters. So how do you find the rows? How do you restrict the rows of interest? Well, this is sort of the general idea here, is that there might be a scan that takes place, and then a second scan for a second filter, and so on. So there's a corresponding operation. So once you've found the rows of interest, you want to go and project the columns required by the query, and that's all this part of this thing. So it's individual scan operations that take place. And this is highly suited for, to get many. So if you need to analyze many rows, the I/O characteristics are generally much smaller for this than a full table scan, and in many cases than even an index operation for significant rows. But what's not in place here is there are some columnar stores with an index capability. But as a general statement, if you found the record based on an index in one column, you still have to do additional I/Os to retrieve the additional records. So column databases for individual row access are going to be, will generally perform poorly because they're doing significantly more I/O for each row returned. But what happens is when you deal with many rows, then that cost goes down, and the fact that bytes not touched because they're not required by the query override that factor. So queries, what's the query suited for? A few rows, billions of rows. What's the general pattern here? So Columnar is well suited for large access to large data sets. You can also do that with a well-architected row DB mess, but that actually depends on the actual functional requirements. Do you need to do a small number of well-known analysis, or is it kind of an ad hoc and a wider capability? And then query variability. So does the system need to do one thing very, very well, or does it need to report on a wide variety of things? So Columnar, traditional technologies are well architected for individual row access, and for well-known use cases, Columnar actually offers excellent flexibility. So there's no difference between scanning column 1 and scanning column 14. It's fundamentally the same operation, and the costs tend to be very similar for those operations. Key takeaways, Columnar great for large queries and flexibility. So the idea that you can scan any column, you can get predictable results for any use case. We've got customers with 500 columns, 200 million rows, and they get basically a very flat performance curve for any query they issue because of the flexibility. Time is up, but we're going to go through this. So column is comparable to large queries dealing with static requirements. So you can go and build a very nice solution with traditional row-based technologies as long as you know the requirements up front. And we can run there as well. Update statements are run either well. And last points down here, Columnar is poor for queries with few records, as well as individual records, insertion and update. The I/O costs for a Columnar database basically go up. They're a factor of the number of columns in the table. And so Columnar databases are generally poor for individual record access.